Okay, this is just a brief video describing how we determine the quadrant the terminal side of an angle falls in based off of the positivity and negativity of two different trig functions. Okay, the first thing we want to do is we want to think about our different trig functions and what the ratios represent. So we know that the sine of theta equals y over r, the cosine of theta equals x over r, the tangent of theta equals y over x, cosecant theta is the reciprocal of sine, secant theta is the reciprocal of cosine, and cotangent is the reciprocal of tangent. With those 6 definitions, we can kind of put together a bit of an understanding as to what's going on here. So we take a look at our unit circle, or our circle in space, and we know that in quadrant 1 the x's and the y's are both positive. In quadrant 2 the x's are negative and the y's are positive. In quadrant 3 they're both x and y are negative, and in quadrant 4 we can say that the x is positive and the y is negative. We're going to use that to figure out where things are positive and negative. So I'm going to start looking at the sine of theta. I will also look at the cosine of theta. And then last we will look at the tangent of theta. I'm not going to be discussing the reciprocal functions because obviously the reciprocal of sine would have the same plus or minus value as sine. Okay, so if we think about sine as being y over r and we're in quadrant 1, then in quadrant 1 we will see that the y value is positive. The y value is positive, as is the r value. The radius is always positive. So in quadrant 1, sine will be positive. Sorry about that. Sine will be positive over positive, which we know equals positive. I'm going to stick with sine for now. Quadrant 2 is y over r again, so the y value is positive in quadrant 2. And again, we always know that the radius is positive, so plus over plus will give us plus. In quadrant 3, the y value is negative, divided by a positive radius, gives me a negative overall quantity. And same thing, quadrant 4, negative y over positive radius gives me an overall negative. I want to do the same thing with cosine now. Cosine in quadrant 1 is, so cosine is x over r in quadrant 1. That's plus over plus, which is plus. In quadrant 2, that's minus over plus, which is minus. In quadrant 3, the x value is negative. The radius is always positive. Negative over positive is negative. In quadrant 4, the x value is positive. The r value is also positive. So again, we get plus over plus here, which gives us a positive overall value. And then our last function is our tangent. Tangent is y over x. So in quadrant 1, that gives me positive y over positive x, which is an overall positive value. In quadrant 2, I have positive y over negative x, which is an overall negative net. In quadrant 3, I have negative over negative. Double negative gives me a positive. And in quadrant 4, I have negative over positive for y over x. That gives me an overall quantity of negative. So when I'm taking a look at all of these guys, here's what I see. I see that sine ends up being positive in quadrant 1 and in quadrant 2. Cosine is positive in quadrant 1 and in quadrant 4. And then tangent is positive in quadrant 1 and quadrant 3. So there's 2 quadrants that each of the functions are positive in, and therefore in turn there's 2 quadrants that each of them are negative in. Other things that I recognize, quadrant 1 is kind of the magic sweet spot. All of our functions are positive in quadrant 1. That is helpful. As a result, we tend to focus on quadrant 1. And then after that, only one function is positive in each of the remaining quadrants. So if I kind of highlight that here, I can see that in quadrant 2, sine is my positive function. In quadrant 3, tangent is my positive function, and in the quadrant 4, cosine is my positive function. So if I come back up to this overall chart, I could say something like in quadrant 1, all of my functions are positive. In quadrant 2, sine is positive only, and it's reciprocal. In quadrant 3, just tangent would be positive, and in quadrant 4, just cosine would be positive. So if I continue on that thinking, we can say something like this. Everything is positive in quadrant 1, sine in quadrant 2, tangent in quadrant 3, and cosine in quadrant 4. I can use this mnemonic of ASTC, or all students take classes, to help remember in what quadrants each of the functions are positive or negative. Moving forward, we can determine the quadrant of a terminal side, therefore given two pieces of information, as any one will give me two options. So for instance, what I mean is if I say that sine is positive, you can only really tell me that means one of two things. You can tell me that I'm in quadrant 1 or I'm in quadrant 2. Or if I tell you that secant theta is positive, or secant goes with cosine, so that would happen in 1 or 4, because that's where cosine would be positive. But none of those is going to give me just one quadrant, so we need a second piece of information to look for an overlap between the two statements to figure out what quadrant I'm actually in. So we can give that a try. So just a couple of examples where I want you to tell me what quadrant we should fall in. So as I'm working on this, here's some things I notice. The sign of t is greater than 0. So t is just a abbreviation for theta when I can't type a theta symbol. So sine t greater than 0 means sine positive, and cosine t less than 0 means cosine negative. So I need those two things to be happening. Sine t is positive. We said ASTC. So sine t is positive in all and in sine, so in quadrants 1 or 2. Cosine negative means cosine not positive. So cosine is positive in all, so it can't be here. And cosine is also positive in classes, which is quadrant 4. So that means that for the second statement, I'm either in quadrant 2 or 3. As a result, the overlap here is quadrant 2. So let's looking at this guy. This is where they both are happening. So as a result, we can say that this first example, the terminal side of my angle, the reference triangle that I'd be drawing, will be falling in quadrant 2. I can do the same thing down below. So this is saying tangent less than 0. That's tangent negative. And this is secant less than 0. Secant is the reciprocal of cosine. So this is cosine negative. So now I'm going to just do my little work. So tangent is negative. All students take classes. So tangent negative is not all, and it's not tangent. So that means I'm either in quadrant 2 or quadrant 4. For our second statement, cosine negative, ASTC, is not in all, and it's not in cosine. So that means this is happening in either 2 or 3. And once again, coincidentally, my overlap happens to be in quadrant 2. So this terminal side will be in quadrant 2. If I needed to draw my picture now, I would go with this sort of situation where here's my theta, here's my right angle, this is my x, my y, and my r. Last statement is really kind of the last thing that I could do to try to make it more challenging. This first bit of information right here, it's not saying cosine positive or cosine negative in a hidden kind of way. It's saying it very directly, and as a result, people tend to miss it. So really, cosecant t equals 5/3. I'm telling you that that's, I'm telling you that that's positive 5/3. So cosecant is the reciprocal of sine. So I'm telling you sine is positive, and tangent greater than 0 means tangent is positive. This is the best case scenario for me because I know the only quadrant where I have positive and positive is in the all quadrant. So this guy has to be quadrant 1. So again, my reference triangle would fall in quadrant 1, this being x, this being y, this being r. Here's my theta over at the origin here. There's my right angle. And that is a brief summary on how to determine the quadrant that the terminal side falls in.